Good evening. My name is Ketan Sai. Currently, I'm in second year, second sem, I fourth sem project school. The project we are working on is Joyverse. This is the presentation for the second milestone. Okay, let me begin. Joyverse, real-time emotion detection. We've gone through all of this already before in the previous milestone, so I'll just try to uh, speed run through this. Joyverse is an innovative interactive web-based platform specifically designed to empower children and support therapists by detecting and interpreting human emotions in real time through advanced facial expression analysis. Utilizing a standard webcam, it captures live video streams to identify a spectrum of emotions, including happiness, sadness, surprise, anger, disgust, and fear. The platform goes beyond more mere detection, aiming to create engaging and emotionally aware digital experiences that can adapt to the user's emotional state, fostering improved emotional intelligence and communication skills. It seamlessly combines cutting edge AI technology with the intuitive user interaction to offer a unique tool for emotional development and therapeutic insight. So, yes, what we did is build a website for dyslexic children to play educational games on, which uh, involves tracking their emotions as they play and changing the themes dynamically to fit better the emotional state at that time so that the child can enjoy playing it and learning as he does so. Moving on to the next slide. Major learnings from our implementation: full stack interaction, API calls and handling, image data processing, model integration, debugging, and deployment. User experience focus, full stack interaction, my bad. So yeah, in our project, we were uh, advised or insisted to use MERN stack, which includes MongoDB, Express.js, Node.js, and React, as we know. So yeah, we understood how to actually create a React project and run it, and then create a database and store these information into the database via API calling through Express.js. So yes, we did understand a bit about the full stack interaction and how to handle API calls. And as for the image data processing, it was mostly about uh, taking the image from the user as he plays the game and sending it to the model for emotional classification and taking back the result to dynamically change the theme of the games and integrating the model also. For now, we haven't deployed our model, I mean, the website itself, as we are facing a bit of issues with the model in the classification part and stuff. Uh, and moving on to the next slide. Milestone achievement confirmation. Core goal met. The primary objective of an interactive emotion detection experience has been successfully achieved. I mean, yes, we did achieve it, but the problem is there's two issues as of now. An moral concern, which is that which our mentor advised us to change, which is what we were capturing the images of the user as is and storing it, which can cause issues later on. So, to be more ethical, our mentor advised to use landmarks of the face to send to the model and get the emotion back. And there is also an issue of proper classification of the emotion. We'll try to work on that and fix it in a few days. And real-time input, webcam captures and process real-time video input efficiently. Yes, it does. Reliable detection, it's almost accurate, but we would like to polish upon it a bit more. Dynamic front end dynamically responds and updates based on detected emotional states. Yes, it does. I mean, unfortunately, the one I have pulled from GitHub on my desktop right now does not have the feature of capturing images and dynamically changing, or maybe it does, but it's not as accurate as the latest versions. When I did try to pull, it gave me a few warnings that I have made changes in mine and I cannot pull as is. I could have made those changes, but yeah, the one I'm going to present the demo, it might not be accurate. The smooth integration, seamless integration across the entire technology. Yeah, thankfully we have no bugs to deal with as of now, and it's smooth and seamless. Okay, let's go to the next slide. Model selection, transformer VIT. Key reasons for using transformers. Specialized training. The model is pre-trained on the FER plus dataset, making it highly suitable for facial emotional recognition task API and output. Offers an easy to integrate API with a compatible structured output format. Simplifying backend processing. Performance achieves high accuracy with low response time, making it well suited for real-time emotion detection and interactive applications. Efficiency. As a pre-trained model, it required no additional training, helping us save significant development time and computational resources. Scalability can be easily extended to recognize additional emotions and integrated into more advanced pipelines if needed in future updates. Reliability, consistent performance across varied lighting and facial orientations, increasing robustness in real-world webcam conditions. Transformer advantage utilizes self-attention mechanism, which will outperform traditional CNNs in capturing spatial features across the face more effectively. So to put this in a gist, the reason we have used vision transformer is because instead of a CNN model is because it's a transformer model. Transformer model tend to retain the features which they have learned because there's this concept called self-attention, through which transformers can understand the context of the data and train better and be more efficient, accurate, and they're generally easier to train. Not easier to train, but easier to send and get output. You know what I mean? So yeah, that's why we choose the transformer, vision transformer for our model. But we could have considered the other models such as OpenCV and custom trained CNN, multimodal models, Network Plus. And these are the reasons why we have choose not to do so. Because Plus is considered, but it is a bit outdated and lacking comprehensive documentation. And CNN requires significant training time. Yeah, this is what I was talking about. Transformers, for some reason, it was really smooth. I mean, I really have to dwell deeper into it why it was trained faster because the person who worked on I mean, in our team, the one who worked on the model got it done pretty fast, to be honest, compared to the previous sem when we were trying to build a CNN model. It was quite fast. Uh, so yeah, it can be trained faster, so we could choose it over CNN. OpenCV classical OpenCV is a Python module, I guess. But the problem is it offers a lower accuracy compared to the modern deep learning models for emotion detection. So yeah, the chosen model offers the optimal balance of performance, accuracy, and ease of integration for our drivers. Architectural diagram changes. So yeah, this was before and this is after. The only thing we majorly changed was instead of using a clip transformer and stuff, we just stick to a VIT. And instead of using Flash for the API calling and communicating with the transformer, we changed it to a fast API. And apart from that, it's mostly the same. The revised architecture, several optimizations with implemented were to remove performance scalability. Okay. The Flash-based backend was replaced with Fast API, as I've said before. And state emotional detection now leverages a vision transformer model instead of a earlier clip plus ML head setup, enabling higher accuracy and faster inference. The middleware continues to manage all API communication, now streamlined through fast API endpoints. Additionally, MongoDB Atlas remains a central database providing reliable cloud-hosted storage for user data, therapist insight, and emotional analysis. This updated architecture results in more responsive and maintainable system. So yeah, that was the changes done in the architecture compared to Milestone 1 and currently what we are looking at. The client is side is done in React. The API calling is handled by Node.js and Express, and the database used to store is MongoDB, and we are accessing it through Atlas. And yeah, communicating with the model is done by fast API endpoints, which is better for our async requests. Async is basically basically handles request and response stuff, which is used a lot in Express.js for API calling and stuff. Challenges and hurdles faced, model integration delay. Yeah, this did take a lot of time to be honest. Connecting the vision transformer model with a fast API and making work smoothly with the Node.js part took longer than expected. It did indeed. Webcam data handling, capturing and sending live webcam images from the browser to the backend reliably caused problems with consistency and speed. MongoDB schema design. Organizing emotion data in MongoDB values to be flexible for both game rules and therapist reports was difficult. Yes, it was, and we are also actually thinking of changing the schema a bit because right now it doesn't store which user was playing the game at that point. The emotion was captured. We are thinking to include like what the game was, who is the user playing, and what level was he in, and what was the emotion tried, what was the theme, and by changing the schema to be as such, we could store every data log in a game session and send it to LLM model to get a summary of our gaming session and save it in the therapist's side so that he can review it later and see what his patient has been doing and what he could improve upon. It should be better. And but yeah, for now we haven't implemented that LLM thing for the summary. We will do it later on. So, uh, deployment complexity, getting the front end related model and cloud database all work. Well, I required many tests and adjustments. Yes, it did. We struggled a lot with that. I mean, I was mostly working on the front end part, but I did see my team members uh, scratch their brains a lot of days to integrate it. I will learn though how they did that. And yeah, deployment. On the front end hosted a static website suitable for local deployment or platforms like Vercel. We haven't deployed it as of now because there's still improvements to be made. But once it is done, we are thinking to deploy it using Vercel. And middleware Node.js Express backend runs locally on us servers such as Render or Railway. Model inference, no direct deployment. Model inference handled via fast API, eliminating local model. So yeah, we just send the image through fast API and get the result back. There's no need to deploy the model. The streamlined approach significantly reduced infrastructure complexity, ensuring rapid setup and easy scalability by upgrading to a dedicated backend server if needed. I think I should speed up. I've been yapping for a long time. I'm sorry if this is long. Code snippets. Here are some of the code snippets of my working project. Let me look at the timer. Okay, it's almost 11. I'm hitting the deadline. So yeah, this is the child registering API endpoint, which we verify using the Thunder client. Okay, let me speed on this. App.post, this is the endpoint API register child. What this is doing is using Express.js to verify if the email is an email and if the password length is at least 6 and you get it. This is quite readable. And the parent email is an email and normalizing it. So yeah, this is taking the input and this async. Async is used to handle promises. I mean, get a request and response and get back the promise. Promises is the output of a request, by the way. And try constant errors, validation result request. So yeah, it is seeing if there are any errors because of the request. I mean, we are storing that in an errors variable, and if not errors is empty, if this means if there are errors, return this. Else we'll just make a constant email, password, child name. We are basically initializing various variables at once from request.body, and we are storing them in this. And we are checking if this is an existing user. We are checking the email, comparing it. This is await. Await means wait uh, for that response to come back. So user dot find one email. We are checking if this exists or not. If it exists, we'll say it exists. Otherwise, what we'll do is we'll hash the password. Hashing is basically, let's say 123. I'll change that into some different formats so that it's not easily readable. And we'll hash it and we'll store it in the database. Await new user dot save. Okay. And we can Thunder Client is a lightweight uh, application through which we can check if our API calling is working properly. And yes, through this we can see that it is being stored properly in the database. This is also similar. The child login and therapist. We are seeing if the data is invalid. Res dot 400, that is error 40, error for the request sent, and find one email to access denied, error 401 access denied. So yeah, this is quite readable. This is similar to the previous one, and we can also verify the login using Thunder Client. This is to check if the uh, let me try to find the line which I'm trying to say. Email is active, true. Restaurant access denied. Ah, yeah. Is password valid? Await by crypt. Compare password user dot password. So yeah, we'll compare. We'll check if the email exists, and then we'll compare the passwords. If so, we'll say in both cases, if anything fails, we'll just say it's denied. Check your credentials. Easy, simple, right? Okay, okay. Moving on to the demo. So yeah, this is the project folder. I'll take you step by step on how we run our project. This is the Joyverse folder. We go to the front end Joyverse app. First thing we have to do is connect to this local server. So I'll just run it node server dot js. What this does is basically start the backend. So if I do login, it will check if the data is correct or not. So once I've started the backend, I'll start the app. npm rundev. This is npm means node package manager. Rundev means when we say rundev, it will look for dev. I mean what file to run in the package.json, and it will run this. So yeah, this is the localhost link. Let me click on that. Okay. Okay. Thank you. So yeah, this is the dashboard. Dashboard. No, this is login page. My bad. Get started goes to join Joivers. I'm a therapist, I'm a child. If you're a therapist, you can log in with the name, address, phone number, license number, as in the therapist's license, doctor's license, password. Unfortunately, as of now, I don't have the credentials for this because I've never logged into this. I'm sorry. But for the child, I do have one. Uh, I can actually make one right now, actually. Let me try. Okay, then age, let's say 5, parents, email, mm, parent@gmail.com, password 23456 7. Let's see. So yeah, registration successful. Welcome to Joy was Little Star. Welcome back, Ketan. So yeah, choose an activity below. Let's have some amazing fun. So this is the child's dashboard. As you can see, we have multiple themes changing constantly, not in immediately, but at regular intervals to grab the child's attention, because nowadays kids have a really less attention span. Uh, it, this is not the most intriguing, but we can try to do better. These are the games right now, and as I've previously mentioned, the version I have and my friends have is a bit different. This is why this game is included. In this game is not included. So yeah, these are the games. Let's go to this Pac-Man Quest. This is a retro theme game where the child can use arrow keys to control the character and eat colors. Uh, okay, let's see. It says target color is red. Let me eat all the reds I could find. Okay, now blue, huh? Okay. So yeah, you get the idea. As you progress, it gets harder. The walls getting this, and yeah, once you hit the wall, you are dead. You could just retry. There's a bit of themes. We'll try to change this dynamically through the emotion analysis. That's one game done. I'll only try to show you one more game because this is getting already longer. I'm almost hitting the deadline. So yeah, this is Missing Little Bob. This is the one my friend worked on. Here you can just click on this. Okay, J underscore jump. So yeah, missing letter pop. Which is a missing letter? U. Quite simple. The child can learn basic vocabulary and stuff through this. SOFT soft. Fi Fi. Okay, five. Five. Okay, sorry, five. Why did that take so long? Anyway, so yeah, this is a game. I mean, we try to cover basic stuff which a child would need. Memory, memorization, trying to know which color is what, basic max and basic vocabulary. Even this is quite simple. Welcome to Space Math. Your journey begins now. 3 plus 5, 8. 5 plus 9. Wow, 14. And yeah, let's try to answer wrong for one. Not quite right. Okay, that was too fast. Maybe we'll have to fix that one. Let me try again. Yeah, that is too fast. You're almost there. You need six more questions to the next level. So yeah, we only need a few questions answered in all of those. And yeah, this is the theme changing. We'll try to. I mean, as I previously mentioning again, this is not the final version. We'll just expand this to fit. Okay. I'm running out of time. So yeah, this is the extra fun activities for the child to play while he's bored. Because who wants to study all the time, right? So yeah, this is art studio, which includes just this is let me be honest, this is just basic MS Paint. So yeah, you can just draw stuff. Willing, I think that's a save one. Yeah, you can save your artworks. Encourages encourages inner Picasso of the child. Music fun. This yeah, day mode, night mode. You know, eyes do hurt a lot. Press any key on your keyboard for random piano sounds. Let me just. I don't know if this is audible, but yeah, it is playing. This is just mindless entertainment for the child to be indulged in when he's bored. So yeah, this is as simple as it can get. Uh, so yeah, that was about it. This was a project Milestone-2 video, and this is what I had to present. And yes, I will ensure that we will work on it a bit more and try to fix some stuff and have it a bit more, what is it, attention grabbing, because some of the themes are not right and not do not adjust properly to the eyes. So yeah, we will work on that. Mm, thank you.